Hey everyone. Okay, so today we're going to dive into Unit 2, and Unit 2 is on measurement. So this one is a little larger. It's going to take us a bit more time. We'll focus on it for a few weeks here, and we'll talk about things like capacity and volume and surface area and mass, and we'll deal with different units from the metric system and from the imperial system. Okay, some of that will have us looking at fractions. Um, I know fractions are a little scary, so we'll take our time with that one, and we'll figure it out together. So don't worry. Okay, but today we're going to focus on reference and the measurement system. So this is lesson 1. Okay, so just a quick little history for you here. Before measuring tools were created, people often used common objects as an aid or a point of reference in measurement. Okay, so we have a cubit. A cubit went from the tip of your finger to your elbow. Okay, um, this is probably one that is one of the oldest units of measurement we know. If you think about world religions, three of the main world religions are Judaism, Christianity, and Islam, and all three of those share a common story of Noah's Ark. And if you look at the ancient texts, the dimensions of the ark was measured in cubits. So, like, we're talking a long time ago. Okay, King Henry declared that the yard should be defined as the distance from the tip of your nose, or his nose. That's actually a point I want to make in a minute, but the tip of his nose to his outstretched finger. The hand is the width of a clenched fist and is used today to actually still quantify the height of a horse. So one hand is about 4 inches. Okay, the furlong represents the distance a team of oxen could plow without needing rest. Okay, now, again, what is all the problem with this measurement? I kind of alluded to it already when I talked about King Henry. Okay, if you look at these two fellas here, their hand span is going to be quite different. Okay, so there is no consistency. So very quickly, we realized we needed to get consistency in our forms of measurement. So the metric system is one of the best ways, one of the best systems we've invented. It's actually not the first one we invented. The first one was the imperial system, but we're going to deal with the imperial system in a few lessons. Today, we're just going to focus on the metric system because that's the one actually most of the world uses. Everybody in the world uses the metric system except for 3 countries. Now, for us, though, the United States is one of those countries, and because we're such close trading partners, we in Canada need to know both of them. Okay. Okay, so the metric system, also known as the International System of Units, is the only acceptable use of measure for scientific research and has been adopted by most of the world. It was originally introduced in France after the French Revolution and has been developed and adapted into what it is today. Now, the base unit, we can talk about length, we can talk about volume, or we could talk about mass, okay? And so the base unit is a unit of measurement on which all the other units are based. So for length, we have a meter. For volume, we have a liter. And for mass, we have a gram. Those are all of our base units, okay? So the base unit of measure in the metric system is the meter, the gram, and the liter. And then we have a standard set of prefixes. The great thing about the metric system is everything works in base 10. So converting between units is often as simple as moving your decimal place to the right or to the left. And I'll show you that in 1 second. Okay. So I've already said this, but length here is meter, mass is gram, and volume is liter. Okay. So we have kilo, hecta, deca, unit, deci, centa, and mila. Now, I just want to talk about this for just a few minutes here. I'm just looking for my ink. Let's just turn this on for 1 second. Okay, so if you think about this for a sec, let's say my base was a meter, okay? Well, then we have a kilometer up here, okay? It's just kilo with the word, oh, sorry, my ink is doing something funny there. We have a kilometer, which is just the meter with kilo in front of it. Okay, so that's something that we know we're fairly comfortable with a kilometer. Or down here, we also have a centimeter where we see a lot of those, or a millimeter. We know that there are 10 millimeters in every centimeter. Okay, so when converting metric system measurements, we move the decimal to the left or to the right, depending on whether the new unit is to the left or right of the current unit. The decimal place moves the number of steps the new unit is from the current unit. Okay, now the example I just gave you was meters, but look, what if, I'm just going to erase that, and what if I said, hey, I'm going to make it be liters now, okay? So I could have a milliliter. Okay, if you think about a can of pop is 355 milliliters. Milliliters and liters are usually the only ones you hear a lot of. But like we could think about a kiloliter for a second. If you think about the trains that go by when you're stuck at an intersection watching all of the oil tanks, if you look beyond the graffiti and look up at the top left side there, you would see the measurement in kiloliters for that tank. Okay, or we could go grams. So if I had this as grams, my ink is a little slow here today. I don't know why, sorry. Okay, that's really bad writing, but you can see it there now. Let me see if I can fix that A for you. So we can have milligrams, okay? I think about maybe like Tylenol or Advil. If you have a headache, if you took a regular strength Tylenol, that's 350 milligrams. If you took an extra strength Tylenol, that's 500 milligrams, okay? Grams, you'd often see like maybe deli meat is sold by the 100 grams. Kilograms, if you think about yourself, actually, if you went to the doctor, you would be measured in kilograms. Okay. All right. Awesome. So, pro tip, use the following acronym to help you remember the order of the metric unit. And the acronym is the following. King Henry died unexpectedly drinking chocolate milk. Now, just remember this unexpectedly right here, that stands for the unit. So that could be your grams, your meters, or your liters. I want you to notice, if you're paying close attention, I just spelled meters and liters two different ways. You can spell it M-E-T-E-R-S or M-E-T-R-E-S. One is kind of the English version and one is the French version. Okay, just if you're paying very close attention, I didn't want to confuse you. Okay, a referent. A referent is something that is not a measuring device being used as one for the purpose of estimation or discussion. Referents lack accuracy because they can differ from person to person. So like say you can't see the I'm sitting at a table right now, but say I wanted to measure this table in cell phones because I have a cell phone handy. Okay, so what I could do is I could just go, oh, it's like 1, 2, 3, 4, 5, 6. My table is like whatever 12 cell phones long. Okay, not super helpful unless I knew what a cell phone was as far as length, but it could be used to compare things. Okay, the meter is the base length, the base unit of length in the metric system. The meter measures distances, square meters measure area, and cubic meters measure volume. All right, so in our class example number 1, we're going to determine a possible referent that you could use to measure the following metric units. So we're thinking about what is roughly 1 centimeter, okay? And the easiest one there would be the width of your pinky finger, okay? Roughly from there to there is a centimeter. Now everybody's pinky finger is a little different, so it's not exactly a centimeter, but it's a good reference. It's a good close thing. A millimeter might be the thickness of a dime if you've got a dime in your pocket, okay? A meter would be usually the height of a doorknob or the width of a door. Those are about a meter, okay? And then a kilometer, a great way to measure a kilometer, it's about the distance you can walk in 10 minutes, okay? So if you think just at a normal walking pace, how far can I walk in about 10 minutes? That would be about a kilometer, okay? Okay, so use a referent to estimate the lengths of the following objects. Okay, now these will be subjective because I don't know what your desk looks like compared to my desk. Okay, but the width of a desk is going to be roughly about a meter. The length of a classroom, I'm thinking about my classroom at school, but you can think about your classroom if you don't go to my school. So it's about 8 meters, 8 doorways. The distance from our classroom to Petro, again, this is a little biased because my school is right by a Petro-Canada gas station, but it would be probably a 5-minute walk. So if it would be probably a 5-minute walk, and we just said that a kilometer is about how long it takes to go 10 minutes, we could say that it's about half a kilometer. Okay, the height of a door, 2.5 meters. That one's probably fairly standard for the doors at your house or the doors at your school, about 2.5 meters. Okay, so now what we're going to do in this class example number 2 is convert the following measurements. So in order to do this, I am just going to write up top here, King Henry died, died unexpectedly drinking chocolate milk. And I'm going to think about 55 centimeters to meters. So that's going from C to my unit. So I'm going 1, 2, 2 to the left. So 55, my decimal is right there right now. So I'm going to move that 1, 2 to the left, and it's going to be there now. Now, remember, we don't start a number with a decimal. So my answer would be 0.55 meters. Okay, so 55 centimeters is the same as 0.55 meters. Okay, so I've got the sentence down there and I've got the 0.55 meters. Now let's take a look at 1,457 grams and we're going to see if we can put that into kilograms. Okay, so I'm going to go from grams, which is my unit, and I'm heading over to kilograms. Okay, so how do I do that? I go 1, 2, 3 to the left. Okay, I'm just going to put a little arrow there to remind us of the direction. So right now, my decimal place is right there. So I'm going to go 1, 2, 3 to the left. So that'll equal 1.457 grams. Oh, sorry, kilograms. My bad. Okay, great. Now I want to go 0.46 decameters to decimeters. Now, decameters to decimeters, deca is the DA. All right. So first thing I'm going to do here is just erase what I've got. So I'm essentially going from deca to deci. So I'm going 1, 2 to the right. Okay, so right now my decimal place is right here. If I go 1, 2 to the right, I will end up with 46. Okay, so let me put those two on here for you. Okay, you feeling okay about this? We got this. Okay, kiloliters to milliliters. Okay, so kilo is this guy here. Mila is this guy here. So we're gonna go 1, 2, 3, 4, 5, 6. 6 places after our decimal. So I'm gonna write this 3.2 for a sec, and I'm gonna go 1, 2, 3, 4, 5, 6. So what happens is, there's my decimal. Any hole that I just created, I put a 0 inside that hole. Okay, so that's going to be 3,200,000. Okay, remember, we try and group these things in groups of 3. So when I go to write this pretty, I'm going to think, okay, well, here's a group of 3, and here's a group of 3. So I'll put a little space in between those groups of 3s. Okay. All right. Great. Now, that sets you up to try on my own. So I want you to pause me, try on my own number 1, and then come on back when you're done. Okay. Hey, welcome back. Okay. Capacity is the next thing I want to talk about. Capacity is the maximum amount that a container can hold. Okay, and it's often used when we're talking about liquid measures. So the basic metric unit for capacity is a liter. 1 liter is the same as 1,000 centimeters cubed. Okay, so we can also say that 1 centimeter cubed is the same as 1 milliliter. Okay, because there's 1,000 milliliters in 1 liter. All right, so that's all I had to say. You're going to try on my own number 2. Now you're thinking, hey, you didn't give me any examples, because it's done the exact same way as on my own number 1. It's just that I had to talk to you about the unit of liters first instead. Okay. All right, so now you are done on my own number 1 and on my own number 2. And we're going to take a look at just a couple more vocabulary words. So mass and weight. Mass is a measure of the quantity of matter inside an object, measured in like grams or kilograms or whatever. Weight is actually the measure of the force of gravity on an object. People often use these two things as a synonymous word, but they're not really. If you went to the moon, your mass doesn't change, but your weight does. That's why when you watch people who are walking on the moon, they're like, it almost looks like they're floating when they take a walk. Okay, and that's because the gravitational pull is not as great. So, although not correct, people often use the word weight to mean measuring mass and mass to mean measuring mass. Weight and mass they use synonymously, but it's not actually. In the metric system, the kilogram is the most commonly used unit of mass. A kilogram is the mass of 1 liter of water at 4 degrees Celsius, just in case you wanted like the exact definition. Okay. All right, so we have basic metric units. We have 1,000 grams in a kilogram. We have 1,000 milligrams in 1 gram. And then we have 1,000 kilograms is actually 1 ton. Now, this would be where my King Henry died unexpectedly drinking chocolate milk. It helped for the first two, but then this second or this third one, you're going to want to set up a proportion for. So the ton is often called the metric ton because there's another ton. We'll talk about that one later. Okay. All right, so let's take a look at class example number 3. What is the total mass of a loaded truck if the truck has a mass of 3.5 tons and it is loaded with 15 skids of boxes that have a mass of 115 kilograms each? Now, give your answer in tons. So what you want to do is you want to take a look at, okay, if I have to give my answer in tons, I already know I have 3.5 tons. But then I have 15 skids, and every skid is 115 kilograms. So the first thing I want to do there is figure out how many kilograms all those skids are. Okay, in order to do that, I'm going to end up multiplying. So I'm going to multiply 115 by 15, and that gives me 1725 kilograms. Okay, now it said answer in tons. So I want to take that 1,725 kilograms and convert it to tons. In the last slide, we just talked about the fact that there was 1,000 kilograms in 1 ton. And so essentially, I could set up a little proportion if I needed to. I could say, hey, there's 1,000 kilograms in 1 ton, and I have 1725. And I'm trying to figure out how many tons that is. Okay, so essentially I'm going to go, if I went to cross multiply this, I would go 1725 times 1 and then divide by 1,000. Okay, so that's going to give me 1.725 tons. Now, that's the weight of the skids, but I also have to take into account the mass of the truck as well. So I have to add to that the 3.5. Let me just erase my ink there so it's not in your way. Okay, I have to add to that the 3.5. And so then I will get a total of 5.225 tons. Okay, so the total mass of this loaded truck will be 5.225 tons. All right, awesome. So now you're ready to take a look at on my own numbers 3 to 6. Okay. All right, and then when you're done on my own 3 to 6, you'll actually have done everything you need to do for this lesson. Okay, so hopefully this makes sense. Keep practicing, keep working through, and keep asking questions. You guys can do this. All right, we'll talk soon. Bye bye.